Welcome back to the deep dive. We've got a really fascinating topic today. Straight from Taiwan, a place Jensen Huang calls the epicenter of the computer ecosystem.
So that's right, we're digging into the recent NVIDIA keynote, the one CEO Jensen Huang gave at COMPUTEX 2025. Lots to unpack there.
Yeah, we've got the transcript excerpts, so we'll be pulling out the key insights, the big announcements, basically giving you a shortcut to understanding where NVIDIA thinks this whole thing is headed.
And the location, Taiwan, was clearly intentional. He spent time emphasizing its importance, their partnerships there going back 30 years. He said it's where new markets get created.
Okay, so let's get into it. Jensen started by looking back at NVIDIA's journey, 30 years. It's really a story of constant reinvention.
Totally. Started as a chip company, sure, but then CU Day in 2006, that really shook things up for computing back then.
And then around 2016, he said they saw this new kind of computing coming, AI-driven. And it wasn't just about faster chips anymore.
Right. It needed a whole new stack.
Yeah.
Processor, software, the system itself. Everything had to be rethought.
Which led them to build the DGX-1, 2016. I remember that. He said nobody really understood it when he announced it, like 0 orders initially.
Yeah, exactly. But they gave that first one to a nonprofit company called OpenAI, and his words, it started the AI revolution. Quite a statement.
Looking back, though, it's kind of hard to argue. They saw something big shifting in data centers.
Definitely. Traditional data centers were all about that north-south traffic, right? Servers talking to storage or the internet.
But AI training needed something different. All those processors talking to each other, that east-west traffic.
It's incredibly intense. And that's why in 2019, they bought Mellanox.
Ah, right. He said they were simply the best at handling that kind of distributed processing, that crucial east-west flow.
And that changes everything. The computer isn't the box anymore. The computer is the data center, a single unit running one massive job.
And the operating system has to change completely for that kind of machine.
Which shifts NVIDIA's role. He was very direct. They're not just a tech company now. They're an essential infrastructure company.
Like utilities, almost.
Exactly. And that's why they started releasing those 5-year roadmaps, which is pretty unusual for tech.
Why do that?
Because their partners, companies, governments building this stuff, they need to plan huge investments, land, power, finance, years in advance. They need to know what's coming down NVIDIA's pipeline.
He compared it to electricity, the internet, essential infrastructure, and now AI infrastructure, these AI factories.
Yeah, AI factories. He thinks this infrastructure of intelligence will be baked into basically everything within 10 years.
So AI factory, is that just marketing or is there a real difference from a data center?
He drew a clear distinction. Traditional data centers, maybe a trillion-dollar industry, are about storing and processing information. These AI factories, he argues, they consume energy and produce something valuable.
Tokens.
Tokens, like actual output.
Right. So companies will measure their output in tokens per quarter, maybe tokens per month. He thinks soon it'll be tokens per hour, just like a real factory.
That's a really different way to think about compute production output. And it scales the opportunity massively. He went from, what, a $300 million chip market in '93 to a $1 trillion data center market. And now he sees a multi-trillion-dollar AI factory and infrastructure industry ahead.
Yeah.
The numbers are just huge.
So what's actually driving all this? He was pretty clear it's this combination, this fusion of accelerated computing and AI.
Absolutely. And right at the core of that fusion, the CUDAX libraries.
Ah, yes, the libraries. He said they talk about them nonstop because they're the core of everything we do. That's a strong claim.
It is, but it makes sense. That software layer is what lets the GPU power be used for all sorts of things beyond just graphics, which is where CUD began. It's how they accelerate completely different fields. And he said he'd be showing off some new ones.
Speaking of graphics, he did show that real-time demo with the GeForce RTX 5060, emphasized it was simulation and AI, not just like pre-rendered art.
And the tech behind it, DLSS neural rendering. It's amazing. The GPU only calculates, what, 1 in 10 pixels?
And AI guesses the rest perfectly.
Apparently so. It's fabricating most of the image, but it looks incredibly real. It's that feedback loop you mentioned.
Right. GeForce brought AI to the masses via CUT, and now AI is coming back and revolutionizing GeForce. He said the RTX 50 series launch was their biggest ever.
And CUDX libraries go way, way beyond graphics into pretty much every scientific and industrial area you can think of.
He listed quite a few.
Yeah. Kaikupi for basic numerics, Ariel Shona for 5G, 6G radio stuff, putting AI into telecom networks. Parabricks for genomics, Monai for medical imaging, Earth-2 for climate simulation.
cuQuantum for quantum computing simulation, qTensor for math.
And then the deep learning ones, Megatron, TensorArt, and Dynamo. He called that a new OS for these AI factories. Plus QDF for data frames, QML for classical machine learning, Warp for making C and Python friendly.
Even optimization libraries like COMATH for supply chain problems or the traveling salesperson problem.
And simulation tools like CutESS and CusBars, used for complex engineering, CAE, CAD, fluid dynamics. And then there was Calitho. That sounded huge.
Computational lithography, using AI to speed up making the masks for chip manufacturing.
By 50 to 70 times. That's a massive speed up in a critical process. And he specifically mentioned partners like TSMC, ASML, Synopsys using it.
It shows how these libraries aren't just code, they're actually changing how fundamental industries operate.
That theme, industry transformation, carried through. He talked about telcos next.
Right, the software-defined RAN stack for 5G, 6G. They've been working on that for 6 years.
Yeah, and getting performance similar to dedicated hardware, to ASICs. And what's a software-defined?
You can layer AI on top for optimization, new services, all that.
And he listed a whole ecosystem working on this. Trials with SoftBank, T-Mobile, Vodafone, full stack work with Nokia, Samsung, systems from Fujitsu, Cisco. It's broad.
Quantum computing, too, the CUDA-Q platform.
Yeah, for blending quantum and classical computing. He thinks future supercomputers won't just be CPUs and GPUs, but QPUs too, quantum processing units.
Then he kind of stepped back and outlined how they see AI evolving. Started with perception AI, right? The last 12 years or so.
Understanding patterns, recognizing speech, images, that kind of thing.
Then the last 5 years brought generative AI.
The ability to actually create text-to-text, like ChatGPT, text-to-image. He called it a universal function approximator, or translator.
And now, agentic AI. This sounds like a big leap.
It is, moving beyond just generating a response to actually reasoning, using chain of thought, tree of thought, solving problems, using tools, collaborating.
He called them digital workers, digital employees. That's interesting.
His vision is that enterprise IT departments will basically manage these AI agents, like HR for digital workers, he said. Wild stuff. He even said NVIDIA engineers are using them internally already.
Wow, okay. And what comes after agentic AI?
Physical AI, AI that understands the physical world. Gravity, inertia, friction, cause and effect. Object permanence.
Like knowing you have to go around a table, not through it.
Exactly. Reasoning about physical interactions. He showed an example of generating training videos for self-driving cars that incorporate this understanding. It's essential for robotics, autonomous systems.
And enabling these new AI types, especially agentic and physical AI, requires new computers. Which brings us to Grace Blackwell, GB200, GB300.
Right. These systems are built for what he called inference timescaling, basically letting these massive AIs think really, really fast. And the key is how they scale up, building these enormous computers beyond silicon limits using NVLink.
So the GB300 is the new system. Same size as before, but upgraded chips.
You get 1.5 times the inference performance, 1.5 times the HBM memory, double the networking bandwidth.
And he made that comparison to the 2018 Sierra supercomputer.
Mind-blowing, wasn't it? One GB300 node has the performance of the entire Sierra system, which had 18,000 GPUs.
A 4,000x increase in 6 years.
It really shows how they're hitting that million times in 10 years goal. It's not just faster chips anymore, it's architecture, it's the whole system.
And that architecture sounds incredibly complex. TSMC's CoWSL process connecting chips.
Right.
The NVLink switch. The NVLink spine network.
That spine network figure was crazy, 130 terabytes per second all-to-all bandwidth.
He said that's more traffic than the entire peak internet bandwidth.
For the whole world, yeah, in that one spine. It's just immense throughput.
And the whole rack is like one giant motherboard. Disaggregated, liquid-cooled, 120 kilowatts per rack. That's a lot of power.
He showed partner systems, like from CoreWeave, Oracle Cloud, and mentioned XAI's Colossus or Stargate project.
That huge factory, 4 million square feet, a gigawatt of power, a $60–80 billion investment.
Exactly, reinforcing the idea. These are factories, and the logic is simple, he said. The more you buy, the more you make. Tokens, that is.
Pure production.
And to help others build these sorts of custom systems, they announced NVLink Fusion.
What does that do?
It basically lets partners integrate their own custom chips, ASICs or CPUs, into the NVIDIA ecosystem using NVIDIA's NVLink chiplets. So they get that critical scaling secret sauce, the NVLink interconnect.
Ah, so they can mix and match, use NVIDIA GPUs with their own custom silicon.
Exactly. He mentioned MediaTek, Qualcomm, Fujitsu already working on it, gives hyperscalers, CPU vendors more flexibility.
Okay, shifting gears slightly. He also talked about filling gaps in their product line, creating missing computers for certain users.
Right. Like the new DGX Spark, a desk-side AI supercomputer.
Desk side, how powerful.
1 petaflop, 128 gigs of LPDDR5X memory. The idea is to give AI developers and researchers their own personal AI cloud, right there.
He compared its performance to a DGX-1 from 10 years ago, now on your desk.
Pretty much. Quiet, office-friendly. He said it's in production, partners are launching versions, and he teased everyone can have one for Christmas.
I definitely noted that one.
And then there's the DGX Station, another personal supercomputer, aiming for the highest AI performance you can get from a standard wall outlet.
Limited by your microwave circuit breaker, he joked, but capable of running a 1 trillion parameter model.
Yeah. And the key point he made about both Spark and Station is that they are AI native. They don't need x86 compatibility. They don't need traditional IT software, hypervisors, Windows. They're built from the ground up just for modern AI workloads.
Okay, but most businesses run on traditional enterprise IT. How does AI fit in there?
That was the next big piece. How do you bring AI power into that existing world of x86, VMware, Red Hat, classical apps, without ripping everything out?
His answer seems to be the new RTX Pro Enterprise Omniverse server.
Exactly. This server is designed to run all of that legacy stuff, VMs, Kubernetes, traditional apps on the Omniverse, and also host these new enterprise AI agents handling text, video, graphics.
He said it's shipping in volume, their biggest go-to-market ever.
It's like a major push.
Yeah.
And inside, it's built around efficiently connecting 8 GPUs. There's a new motherboard with a CX8 chip.
He called the CX8 a switch first, a networking chip second, optimized for that GPU to GPU east-west traffic again, 800 GBPs.
It's all about making those GPUs talk efficiently for AI workloads. And he introduced specific metrics for evaluating these AI factory systems.
Right, not just raw speed, but throughput and latency.
Throughput is tokens per second, how much output can the factory produce. Latency is tokens per second per user, how responsive is it for interactive tasks. You need both.
And optimizing for both involves complex software tricks, pipelining, parallelism, batching, speculative decoding. The overall capability is the area under that curve he showed.
And the RTX Pro server performs well on these metrics for enterprise needs. 1.7x faster than Hopper H100 on Llama 70B.
And 4x faster on DeepSeek R1. He seemed quite excited about that model.
Yeah, he called DeepSeek R1 a gift to the industry, a major CS breakthrough influencing researchers. Sounds like its architecture is pretty novel.
Beyond compute, what about storage? AI changes how we handle data too, right?
Fundamentally, humans use SQL for structured data. AI needs semantic search for unstructured data understanding meaning, not just keywords.
Which requires a new AI data platform and GPU.
GPUs are needed for the heavy lifting. Embedding data into vectors, indexing them, searching, ranking results. He predicted future storage servers will literally have GPUs sitting in front of the drives.
And NVIDIA is providing models for this.
Yeah, building and open sourcing things like the Llama Nimitron reasoning model, he called it the world's best, and blueprints like AIQ, NVIDIA AI Query for retrieval.
How much better is AIQ?
He claimed 15 times faster retrieval and 50% better results for those unstructured queries. That's a significant jump for enterprise search capabilities.
And they're working with storage vendors, Dell, NetApp, IBM.
Yep, integrating these models into platforms from VAST, Dell, Hitachi, IBM, NetApp. He showed an example. VAST built a sales research AI agent in just 3 days using the IQ blueprint. Pretty fast turnaround.
The last piece for enterprise seemed to be AIOps, a software layer to manage the whole AI lifecycle.
Right, curating data, fine-tuning models, evaluating them, putting guardrails in place, securing everything. It's the operational side of enterprise AI.
And partners are integrating with this too. CrowdStrike, Nutanix, Red Hat.
A whole ecosystem. He gave a shout out to Jeff Clark for driving this enterprise push. The overall message was clear. Add AI into existing IT, don't force a rip and replace.
Makes sense. Okay, let's pivot to robotics. He made an interesting point connecting AI agents to robots.
Yeah, that agents are essentially digital robots. They perceive, understand, plan, act, just in a digital space.
But the goal extends to physical robots, obviously. And they need to learn in simulation first.
Absolutely, which requires incredibly realistic physics simulation. Rigid bodies, soft bodies, deformable materials.
And that led to the Newton announcement, the world's most advanced physics engine, developed with DeepMind and Disney Research.
Sounds like it. GPU, accelerated, real-time, high fidelity, and crucially, he said it's differentiable.
What does differentiable mean here? Why is that important?
It means the simulation can tell you how changing an input, like a robot's motor command, affects the output, like where its hand ends up. It calculates those gradients. That's fundamental for training AIs using methods like reinforcement learning. It lets the AI learn effectively within the simulation.
Got it. And Newton is being open-sourced, integrated into Mujoko Isaac Sim.
Open sourcing in July, yeah. So the whole autonomous stack starts to look like. Train on GV-Tool 1300, simulate an Omniverse with Newton, deploy on Jetson Thor.
Jetson Thor, that's the new processor for robots and cars. It's in production now.
Yep. And the Isaac Group platform pulls it together. Jetson Thor, Isaac OS for the runtime software, pre-trained models. He mentioned the Isaac Group N1.5 model is open source and getting downloads.
But training robots is hard. Getting enough data is a huge bottleneck.
The biggest challenge, probably, human demos just don't scale.
So their solution is Isaac Group Dreams, using AI to amplify human data.
Right, a reel-to-reel approach using their Cosmos physical AI foundation models. It's pretty clever.
How does it work again? You fine-tune Cosmos with some human demos.
Then you prompt it with images or instructions,
Yeah.
and it generates possible future outcomes as video dreams.
Okay.
Then Cosmos evaluates those dreams. If a dream looks successful, it generates the 3D robot actions needed to achieve that dream.
So it's generating synthetic training data from video dreams.
Exactly. Training trajectories generated from AI-generated videos which were prompted by humans. It lets a small team potentially create massive amounts of data, tackling that bottleneck.
He spent some time on humanoid robots specifically. Why humanoid?
Because they can operate in our existing world, right? Brownfield environments. They fit through doors, use our tools. He thinks it's the next multi-trillion-dollar industry, needing tons of compute and data.
And robots won't just work alone. They'll work together in factories.
As fleets, which means they need to learn collaboration, coordination, again, back to simulation and Omniverse.
Which naturally leads to digital twins. Not just robots, but equipment, factories, even cities. Omniverse enables this.
He showed some really cool examples from Taiwan partners, TSMC using it for fab layout simulation, Quanta, Wistron, Pegatron for virtual factory planning.
Pegatron simulating solder paste, Quanta doing process analysis with Siemens, Foxconn Wistron, Quanta using digital twins as robot gyms.
Yeah, training physical robots in the twin, simulating power and cooling, and connecting the digital twin to the real factory via IoT for live dashboards. Using Metropolis AI agents to help human workers, he really emphasized the partner ecosystem, saying, "My entire keynote is your work."
And city-scale twins, too. Kaohsiung, simulating scenarios, monitoring cameras.
Huge potential there. He mentioned $5 trillion in new industrial plants planned globally, a massive opportunity for digital twins and robotics.
Finally, he circled back to Taiwan itself, reaffirming their commitment there.
They're growing so fast with engineers and partners, they just need more space. So they announced a brand new office.
The NVIDIA constellation in Beitou Xiling.
Yeah, building a major new presence right there in the epicenter. Underscores its importance.
And he had that funny bit about needing the mayor's approval, telling the audience to call him.
Classic Jensen. Said they want to start building ASAP.
So, wrapping it all up, how did he frame this whole moment?
As a once-in-a-lifetime opportunity.
Not just the next IT wave, like PC, internet, cloud, mobile. We've seen those before.
No, he sees this as creating a whole new industry, unlocking completely new possibilities across the board: manufacturing, robotics, science, healthcare.
And the focus is clear. Build AI factories, deploy enterprise agents, enable physical robots, all on one architecture with that huge partner ecosystem. He ended by thanking them.
It really is.
Yes.
So the scope of the vision is just immense when you step back and look at it all together.
Yeah, the shift to AI factories making tokens, digital AI workers, physical AI understanding the world, digital twins mirroring reality. It fundamentally changes what computing even means.
It definitely helps you grasp how fast things are moving and the potential impact everywhere.
I mean, computing isn't just servers anymore. It's infrastructure measured by output, it's digital agents doing work, it's physical spaces being simulated and trained.
So thinking about that trajectory,
Yeah.
what's the next essential utility going to be after intelligence infrastructure itself? Something to ponder.
Definitely. Well, thank you for joining us for this deep dive into Jensen Huang's keynote and NVIDIA's ambitious view of the future.